This is Christian Jewell's Lab 5 here. I ran the MATLAB code. In the figure that popped up, the thin red line is the input, so it's trying to set it to 5 volts. And the blue and orange lines are they show how long it actually takes because of the resistors. So the higher the resistance, the longer it'll take to get there to charge the capacitor. Here's my circuit with 2 outputs that go into analog pins 1 and 2. There's my code behind the serial monitor. You can see the serial monitor is working well. The input's going from 0 to 5 volts. The output is catching up. And there's really nothing too special in the code. I just have it 500 times do tau over 50 delay of printing out the V in and V capacitor with the voltage in set to high, and then I do it 500 times set to low. Going over to my processing, why don't I close the serial monitor here? There's nothing too difficult in here either. I had to do the text and the fill for the labels to the side, as well as the lines, and then the legend up top. I had to do some circles for that with the same colors, and then I changed these definitions up a little bit, the conversions, to bring the 10-bit values in and display them over here. And it looks pretty good. So this is a 100k ohm resistor. I changed the value in Arduino, which will change the time constant. And in processing, it looks like this instead. It's a lot slower. Here's the analysis with the 10k resistor. And here's the analysis with the 100k resistor. And I changed the resistance value in the script. I'll say that the higher resistance made it take a lot longer to get to the signal that was commanded. Here's the MATLAB with the volts on the y-axis instead, up to 5. And how I did this was where I told it to plot, I just changed the Vn and Vc to an equation in terms of Vn and Vc that I derived by making a linear relationship between the processing data, which depended on the size of the screen, and obviously the voltage I wanted. That last one was 10k ohms, and this is 100k ohms, again with volts on the y-axis. So the data sheet shows it's a 10k ohm resistor, and my room temperature here about 70 degrees. It's stabilized around 554, and I wrote a slightly shorter Arduino sketch. In processing, I believe it's stabilized around 2.5 based on lines like that. There's just a lot of noise. The voltage is going down when it's heated. And the voltage goes up significantly when it's cooled. I thought I was short on time, and then I realized I wasn't, so I'll say a few things here. So at one point I had the input from the serial monitor really close, like within 1 or 2 out of 1024 every time, like that, for example. But I think because of the thermistor, it's just kind of finicky. It's got this wide range there. And because it was difficult to hold things like this Freezy Pack and the lighter on, I wasn't able to measure the exact time response, but I do believe it acts as an RC circuit. You would see it in the same way that the RC circuit we did. It would kind of like take a little bit of time to approach the input value when a step input was applied. It was the same way with the hot and the cold. It was just hard to measure that and hard to see it, and at the same time. Thanks. One last thing I wanted to talk really quickly. So because the voltage went up when it was cooled, using this relation here, if we were to try different values, we would find out that that must mean that the resistance of the thermistor is increased when the temperature is cold, and it's decreased. There's a lower resistance when it's hot.